So we can use our compound interest formula for inflation and population growth because they also rise up exponentially, just like compound interest. So compound interest, you're earning interest on the interest. Well, the same with inflation, it goes up a certain percentage each year, and then the next year it goes up a percentage based on that. In population, same idea. If you've got 100 people and then 110 the next year, well, your population's based the following year on the 110, not just on the 100. Okay, so let's have a look what it is. The current price of a 2.5 kilogram packet of sugar is 21 Rand 50. Is that how much it costs? I don't really eat sugar. Calculate the expected price of the sugar in 10 years' time if the rate of inflation remains constant at 6.5% per annum. So it doesn't say the compounding period, monthly, quarterly, but if we're dealing with inflation, then we're dealing with per annum. Yeah, so let's just start. We know what our formula is. A equals P1 plus I to the N. Fill in the bits we know. 21 Rand 50 is what it costs at the moment. 21.50. 1 plus I, well, it's per annum, so this is not too bad. 6.5%. We just need to go 0,065 to the N. Calculate in 10 years' time. Okay, so to the 10 into our calculator, and we get that it's 40 Rand and 36 cents. And inflation is really an interesting one. You always hear people saying, I can remember when something cost so much. Well, if it just goes up at the same price as inflation, well, depending on your GDP and relative earning, then it might just be the same price. Okay, so I think it's going to be worthwhile doing all of these in this same video. A loaf of white bread currently costs 9 Rand 40. Determine how much a loaf of bread, presumably the white loaf, is 25 years ago. Assume the average rate of inflation over the last 25 years was 10.8%. Okay, so we've got our bread. It seems arbitrary that we're focusing on white bread, but I don't know. Some of these things are government subsidized. I don't know if white bread is brown bread. I don't know. Let me know. But the point is that it costs 9 Rand 40, and we need to know how much it cost 25 years ago if inflation was constant over the whole time. Well, I guess it doesn't have to be perfectly constant, because we can just say, well, the average rate over the last 25 was 10.8%. Okay, so A equals P1 plus I to the power of N. And again, I always like this idea of fill in the bits that we know. So in this case, it's currently 9 Rand 40. So what was it principally? So 25 years ago, what was it? So 1 plus inflation, so we just go annually, and it was 10.8, so 0.108, 25 years. And all we need to do, let's divide that whole side by 1 plus 0.108 to the 25, so that those whole things kind of cancel. What do we do on one side? We do on the other. 1 plus 0.108, 25. Do my little arrow thing that I seem to love so much. And what do we get? Calculator. This comes out to 0.72. So in other words, another way of writing that might be 72 cents. So ask somebody that was around 25 years ago. I was, but I don't even know how much bread costs now properly. So 72 cents, 25 years ago. When was that? When 2020. So what's that, 95? In 95, a loaf of bread, I don't know how accurate these are, these figures here. Maybe it was 72 cents for 95. I don't know. Anyway, let's onwards, upwards, right? Okay, so we got another couple of examples. I think that's it. And a couple of examples here are to do with zebra in the Kruger Park. Okay, so in 1980, apparently there were 22,500 zebra. And you notice I'm circling the things as we go, and it's not something that I'm consciously doing now. You notice in some of the other ones I've circled in a particular color and then use the same colors. For now, I'm really just circling the bits of information and trying to extract those out of the problem. In 2010, okay, so there's a bit of hidden information here. Oh, except that it's not too hidden. There were 30,000. Calculate the average percentage increase per annum of the zebra population over this 30-year period. So we didn't even have to work out that that was 30 years. So after all of that, like, that information wasn't even that useful. Went from 22,500 to 30,000 in 30 years. Determine I. Like, that would be another way of writing the question. So A equals P1 plus I to the N. It wasn't too long ago that that formula was not a mystery, but it was just a brand new concept. And now we're like, A equals P1 plus I to the N. I don't need that formula sheet. Okay, so what do we get here? A, so it rose to 30,000. Dung, dung, dung. It started, the principal amount was 22,500. 1 plus I, we don't know. N, 30 years. And bits per annum. This isn't compounding monthly. So we just need to get to I. Well, we did a few of these examples. In fact, this is what we're doing the day before you're watching this video. Or it's difficult to say yesterday, today, I don't know. So first of all, we divided, but we did these already. Divide both sides by 22,500 because, you know, those things there are like goodbye. That you punch into your calculator. So I'm going to do it. 30, 1, 2, 3, divided by 22,500 equals, and then I know, hey, 4/3, that worked out quite nicely. So 4 over 3 equals 1 plus I to the 30. Remember, we don't have to show every little step here. So I would think that first equation, that was crucial. But after that, we got 4/3. We know we're taking the 30th root, so we're going to go shift 30 of 4 over 3. I should have used the aunts there, hey? That would have been cleverer. Aunts. That sounded funny. And then after that, we're going to have 1 plus I, so we can subtract 1. So we've got I equals. Now, this is another one of those with that ENG button we're going to need. So at the moment, I equals 0. No, not 0. 9,63552. A whole lot more things. Times 10 to the minus 3. Okay, but we want I as a percentage. So we just go times 100 equals 0,96% per annum compounded annually if we were to do that. Okay, so it wasn't too bad. Remember, this here is just so that I can show on your calculator a bit more clearly. The population of Cape Town was 3.6 million at the end of 2011. Okay, so lots of people in 2011. Calculate Cape Town's expected population based on this figure at the end of 2025 with a growth rate of 1.3%. Again, I wonder how accurate these figures are. So we need to work out how many years this is. Well, there, whoop-de-doo, right? That's not too bad. I say whoop-de-doo because it's not, I don't feel like it's too bad to figure that. We know 1 plus I to the N. Okay, so we're going to grow. Well, that's what we don't know, so we're going to find that out. We're going to start with a principal amount of 3.6 million. Now I think 3.6 million. Well, let's just look here. 3 million. 3 mil would be 3 and 6 zeros. So 3.6 million. See how cool I am. Did I just say mil? No more rapping, right? So that's 3 million was 3 and a whole lot of noughts. So 3.6 is like 3.6. And then match up those noughts. So you still have these 6 to see like how many noughts, how many zeros in it. So 3,6, I think we had 3,600,000. 3,600,000. Yeah, that seems to fit in. Plus I, no, we know what I is. 1,3. So 0,013, because that would be 10%. 1, yeah. N, well, this was the whoop-de-doo part, right? 2011 to 2025, 14. So into our calculator, and we get 4,313,549. So in other words, this is approximately equal to 4,3 million if we were to do it in those terms. 4,313. I don't feel like that figure's anywhere close to right for this annual growth rate, but who knows. Okay, so that's that. So basically, inflation and population growth is really just compound interest in a slightly different context. Okay.